Hey, Math 186 friends. Moving on into section 8.2, law of cosines. Let's just briefly review what we talked about in 8.1, law of sines. Now remember, the purpose of 8.1 and 8.2 is to solve triangles. That is, given some information about the triangle, we want to find the remaining information. So all triangles have 3 sides and 3 angles. We need to know at least 3 of these parts, one being one of the sides, in order to solve a triangle. Last class we talked about the law of sines. The law of sines gives a relationship between the angles, the measure of the angles and the lengths of the sides, and it says that the sine of any angle over the side opposite is equal to the sine of any other angle over its opposite side. And that relationship holds for all 3 angles and all 3 sides. Depending on what we're solving for, we could use the reciprocals. We could say the length of side A over the sine of angle A is equal to the length of B over the sine of angle B, which is going to be the same ratio as the length of side C over the sine of C. So you can use either one of these ratios to solve a triangle if we know one angle and its side opposite. So the purpose of that being, if we know one angle and the measure of the length of the side opposite that angle, then we'll know one complete ratio and we can use that to solve for all the other ratios. So we use the law of sines when you know both the measure of an angle and the length of the side opposite that angle. I think that's that's easier to remember than remembering the types of triangles. So we use law of sines for cases 1 and 2. Cases 1 was the angle side angle case. That's when we know 2 angles and the included side between the 2 angles. Or if we know one side and 2 angles, we can also call that an angle side, because if we know 2 angles and the following side, we automatically know the 3rd angle once we know 2 angles. So then we would know all 3 angles and the side opposite one of those 3 angles. We have to be really, really careful if we know 2 sides in a row, then the angle, so side, and then the non-inclusive angle, or affectionately known as the ass case. So these you have to be really careful for. You may get no solutions. You may only get one solution, but you also may get 2 angles that solve, or 2 triangles that solve the given criteria. So be really careful with the side angle, or the angle side case. This case, if you have 2 angles in the included side or any 2 angles in the non-included side, the solution to the triangle will be unique. All right, so what happens if we have some information about a triangle, but it doesn't include an angle and the side opposite? Well, this law of sines will not work. So then we have to refer to the law of cosines, which is another relationship for finding or solving a triangle. So we use the law of cosines for cases 3 and 4. And cases 3 and 4 are, well, what were they? Well, case 4 was the side. And then this was the side angle. Nope. Angle, side angle. No, oh my gosh, I already forgot that case. See, this is why I don't even remember the cases. Just checking for that case. Case 1, case 2, case 3, 2 sides and the included angle. Side, oh yes, duh. Side, angle, side. There we go. So these are the 2 cases. I remember it more, but we use when you know 3 parts of the triangle, but you don't know both the measure of an angle and the length of its opposite side. what the law of cosine says. The law of cosines says for any triangle, now notice how I labeled it: angle A, side A opposite, angle B, side B opposite, angle C, side C opposite. For any triangle, A squared equals B squared plus C squared. So this is starting to look like the Pythagorean theorem, but Pythagorean theorem works for only right triangles. One of the angle has to be 90 degrees. In this case, this works for any triangle. A squared, pick any side, that side squared equals the sum of the other two sides squared minus 2 times the length of B times the length of C times the cosine of the angle that we started our equation with. Now this works with any of the sides. We can switch out any of the values here. What do I mean by that? Let's suppose I started with B squared. B squared is equal to the sum of the squares of the other two sides minus 2 times those two sides times the cosine of the angle across from the side that we started with. And then lastly, C squared is equal to, well, the other two sides squared minus 2, that side times the cosine of the angle we started with. So notice there, what we start with is what we end with. We start with the side, we end with the angle opposite that side, and then what's in the middle is the values of the lengths of the other two sides. So this is the law of cosine. So this holds for any triangle. All right, so let's use the law of cosines to solve, knowing that angle A is 62 degrees, side B is 13, and side C is 7. So given this information, I already drew the picture, but I'm going to label the sides accordingly. If this is angle A, I know side A must be opposite of it. If this is side B, B is 13, the angle opposite is going to be angle B. C, this would be angle C, right there. All right, so we need to find angle B, angle C, and side A. Notice we only know one angle, so we cannot determine the values of these directly. So when we go here and we look, we say, what possibly one could help us here? Let's see. My thought is, we could use the first one, A squared equals, this is little b, let me put it here, little b, little c, and this is angle A. So A squared is going to equal B squared plus C squared minus 2BC. So we know all this information. So that one's screaming at me. B squared, we know B squared. We would need to know for the second one, we would need to know A squared, which we don't know. We know C squared, but then we would need to know the cosine of B. So if we try to use the second template, we don't know B and we don't know A. So we'd have two unknowns in one equation. So this one wouldn't work. And here, C squared, we know C squared, we don't know A, and we don't know angle C. So this also would not work for us because it would leave us with two unknowns. So the first template's the one that we're going to have to use. Now notice, if I tried to use the law of sines here, I would need to know, I only know angle A. So in order to use the law of sines, I would have to know side A, and I don't know the length of side A. So the law of sines would leave us in a little bit of a pickle and we wouldn't get any information from it. So I'm gonna use rule 1, A squared equals B squared plus C squared minus 2BC cosine of A. So A squared is going to be 13 squared plus 7 squared minus 2 times 13 times 7 times the cosine of 62 degrees. All right, now here we have to be really, really careful with your algebra. You may, let me do this first. 169 plus 49 minus 2 times 13 times 7. 2 times 13 times 7 is 182 times the cosine of 62 degrees. So continuing with my algebra, I have A squared. I'm going to add the 169 and the 49 and get 218. You may not subtract 182 from this number because it has the cosine of 62 attached to it, so it's not like terms. Right, so you may not subtract these numerical values. We have just plain old 218 here, and here we have 182 cosines. So A is going to be the square root of 218 minus 182 cosine 62 degrees. All right, not a pretty number, but something we can find in our calculator. I suggest going to at least 4 places after the decimal. 4 places is going to give us the most accurate result. We got 11.5133. Make sure you're in degree mode on your calculator or you'll get the incorrect answer. So that's a mistake where students commonly succumb to. All right, so now we know side A is about 11.5133. All right, so we know all the sides, and we know one of the angles. We have to find one of the other 2 angles. So I'm going to use, let me see, I'm just going to go alphabetical. I'm going to try to find angle B. So I know all 3 sides. The only unknown is angle B. So I'm going to use this second template. B squared equals A squared plus C squared minus 2AC times the cosine of B. So that's the template I'm going to use. Let's fold this for a minute so we can see this a little better. There we go. All right, so B squared would be 13 squared equals A squared, which is, you could put in 180, the square root of 218 minus 182 cosine 62, but typically if you go to at least 5 places after the decimal, you will have enough accuracy. Minus 2 times 11.5133 times C, which is 7, times the cosine of B. Again, be really careful here. We can add these 2 together, but we cannot suck that one in there. Right, so what we're doing is we're solving for the cosine of B. So to solve for the cosine of B, I'm going to bring these 2 terms over to the other side, and I'm just going to leave them like that because I want to stick them into my calculator all like that. So 13, I'm going to subtract 11.5133 squared minus 7 squared is equal to negative 2 times 11.5133 times 7 times the cosine of B. Now again, I'm solving for the cosine of B, so I'm going to take all of this and divide it through. So I'm going to get 13 squared minus 11.5133 squared minus 7 squared all over negative 2 times 11.5133 times 7. And that's going to be the cosine of the angle we're looking for. So you can pop this number into your calculator, but in order to get angle B, what we have to do is get the cosine on the other side. So if we know this is going to be some numerical value, so we know the cosine of the angle B is equal to some number, so therefore the angle B is we're going to use our inverse cosine button on our calculator. We're going to do the inverse cosine of 13 squared minus 11.5133 squared minus 7 squared all over negative 2, 11.5133 times 7. Now half of the battle is getting this into your calculator correctly. Make sure you're in degree mode. I got 85.5322 degrees using the inverse cosine button on my calculator. So let's just go through the steps here. How I would do this is I would do 13 squared, and then I would do minus 11.5133 squared, and then I would subtract 7 squared, and that's my numerator. And then I would divide that by, in parentheses, the denominator of 2 times 11.5133 times 7. So that's what the cosine of B is equal to. And then I'm going to hit second cosine, do the inverse cosine. Now, instead of typing that number in, if you look right above the negative sign, it says answer. So if I go second answer, it's going to take my previous answer and put it in there. Oh, nope. You know why? Because I am in the wrong mode. Ha, see, don't make that mistake. All right, we get back to this. Quit. All right, let's try this again. So now I have to type it in because it'll use that previous answer. 0.0804427,873. All right, there we go. There's my 85.53. Oops. Yeah, it rounded it a little bit because, I'm going to try that again. I'm going to do 13 squared minus 11.5133 squared minus 7 squared. I'm going to divide that by -2. -2 times, in parentheses, 11.5133 times 7, right? So that's the cosine of the angle. And we have second inverse, second answer. And I get 85.5322. Yep. So notice just by typing the number in versus using the answer key, this one's going to be more accurate because it's not only using the digits that are displayed, but it's using many more digits after it. So just be really careful in Alex. If you're struggling, write down the picture and write down the problem or take a picture and send it to me. All right, so now we know, or zoom in and we can answer questions. We know that this is 85.5 degrees, just for, so now angle C is the easiest one to find because once you know two angles in the triangle, we know that the sum of the angles of a triangle equal 180 degrees. So if we take 180 degrees and we subtract the two known angles, 62 degrees and 85.5322, we're going to get C to be about 32.4678 degrees. So yeah, we just solved our triangle. So therefore for a triangle with angle A is 62 degrees, side B is 13, side C equals 7, we get angle B to be about 85.53 degrees. Make sure you just follow the directions in Alex, round accordingly. 32.47 degrees. And we got side A to be about equal 11.51. All right. So let's take a quick peek at this. One way, if you get lost or you're not sure what side you just solved for, one thing to keep in mind is the larger an angle is, like if we start opening this angle up, this side is going to get longer. If we close that side in, this side's going to get shorter. So with the largest angle should always have the largest side opposite of it, and the smallest angle should always have the smallest side opposite of it. So we just got C to be 32.4 degrees. So this we just got to be 32.5 degrees if I round correctly. So the largest angle is 85.5 and the largest side is 13, which is opposite the largest angle. Here's the smallest angle and 7 is the smallest of the three sides. It doesn't guarantee that you didn't make a mistake, but it is a quick catch if you do make a mistake by placing the wrong label on the wrong side. So let's just write that down. Geometry. Okay. Here. So geometry, my reminder, we're going to call this X, Y, and I'm going to call this the longest side. So the sum of two sides is always greater than the length of the longest side. Excuse me. So the sum of the shorter legs of the triangle always exceeds the longest side. And the longest side is always opposite the longest angle. So the longest side is always opposite the longest angle, the largest angle. And the smallest side is always opposite the smallest angle. So just some geometry hacks to keep in mind. All right, so we just solved a triangle where we knew an angle and two sides, and we knew the included angle, which lends itself to the law of cosines. So let's do one more. Let's solve the triangle when we know the lengths of the three sides, but we don't know any of the angles. So A is 20, so if this is side A, this must be angle A. 10 is C, so if this is side C, opposite, this must be angle C. And if B is 12, this must be angle B. All right, so here, and remember, in order to use the law of sines, which algebraically is easier, but in order to use the law of sines, we need to know one side and the angle opposite of it. So we need to know at least one angle to use the law of sines, which we don't know. So we have to use the law of cosines here. In this case, all three of these templates can be applied equally because we know this chunk of it for all of it, and we don't know any of the three angles. So I'm just going to go with the first one, just because it's alphabetical. We're going to do A squared equals B squared plus C squared minus 2BC all over the cosine of A. Remember, we're looking for angle A, so we're going to solve for this. So your book presents another template, which is just simply this template solved for the cosine of A. So this means that A squared, if we subtract B squared and C squared from both sides, and then we divide out the negative 2BC, we get the cosine of A. So you can do this, and then in turn, angle A is going to be the inverse cosine of this whole mess. Negative 2BC. So you can jump right to this step and use this template, and you can create the other two templates for the other two parts of the law of cosines. I always tend to just stick with this and do the algebra. So I'm going to do it that way, or you can just go straight for this template and you'll see that it works out the same anyway. So using this, I get 20 squared equals 12 squared plus 10 squared minus 2 times 12 times 10 times the cosine of angle A. We started with side A, we're going to end with angle A. So now I'm going to do the math here just to show this template. 20 squared, we're going to subtract 12 squared and 10 squared from both sides. We may not subtract this value from those two because it's tagged on to the cosine. Now I'm going to solve for the cosine of A by dividing this piece out. So we're going to have 20 squared minus 12 squared minus 10 squared all over negative 2, 12 times 10. And that's equal to the cosine of A. So we could have gone right to that. So angle A is going to be the inverse cosine of 20 squared, and if you find it easier to pop these numbers in your calculator, feel free, minus 2, 12 times 10, and here we go. Let's find what angle A is. So I'm going to clear my screen. I'm going to do 20 squared minus 12 squared minus 10 squared, and I get 156, inverse cosine of 156 all over negative 2 times 12 times 10, negative 240. So now I'm going to do 156 divided by negative 240, and it would be negative 0.65. So I'm going to do the inverse cosine of negative 0.65. Second cosine, second answer, just so I don't have to type it back in. The answer, again, is above your negative sign. And I get the angle to be 130.5416 degrees. And I use a squiggly equal sign because it's not exactly this. This is an approximation. Here we go. So that's this angle. So we just found angle A. And angle A, it's pretty big. It looks big. It's across from the largest side. So I'm going to say 130.5 for angle A. All right, so now I just have to find one other angle, and then I can use the fact that the sum of the angles inside of a triangle. All right, so I'm going to go for angle B. So B squared equals A squared plus C squared minus 2AC times the cosine of B. Or I can go right to this template. Angle B is the inverse cosine of B squared minus A squared minus C squared all over negative 2AC. So angle B is going to be the inverse cosine. B squared is 12 squared minus 20 squared minus 10 squared over negative 2 times 20 times 10. All right, so let's pop that all into our calculator. 12 squared minus 20 squared minus 10 squared divided by, make sure you put the whole denominator in parentheses, negative 2 times 0.89, and then I'm going to do second cosine, inverse cosine, second answer. I get 27.1268 degrees. So now the last, we go here, we know that this is 27.1 degrees. That would be B. 27.1 degrees. So to find C, the angle, the sum of the three angles must equal 180 degrees. So angle C is going to be 180 degrees minus 130.5416 minus 27.1268 degrees. All right, so I'm going to do 180 minus 130.5416 minus 27.1268, 22.3316 degrees. And that's the remaining angle right here, 22.3 degrees. All right, so let's just double check. The largest side does have the largest angle opposite of it. The smaller side has the smallest angle has the smallest side opposite of it. Notice these aren't very different, 10 and 12. There's not much difference between the sides. Likewise, there's not much difference between their opposite angles. But 27 is bigger than 22, and the side opposite 27 degrees is longer than the side opposite the 22 degrees. So let's just write that down. We have, so therefore, given side A equals 20, side B equals 12, and side C equals 10, we get that angle A is about equal to 130.5 degrees. Angle B is about equal to 27.1 degrees, and angle C is about equal to 22.3 degrees. Review. To do. Read 8.2. Exercises in the textbook, 7, 9, 11, 15 to 33 odd. There is a lot of problems. Hopefully you have a lot of time on your hands to do these. Alex, 7% plus or 5+ hours for this Wednesday. What is this Wednesday? 4/8. Next Wednesday, it's going to be 38% plus or 5+ hours for Wednesday 4/15. Just to give you an idea, see, now I have an extra space here, 58% plus or 5+ hours for Wednesday 4/22. And then the week after will be 100% because your exam is the last week of April for chapter 8 and chapter 11. It's 8 and 11 combined. We're just doing several sections in 8 and several sections in 11. All right, don't forget, retake for exam number 2 tomorrow. Opens at 8. Anybody has any questions, concerns, be sure to zoom in. Hope everybody's doing great. See ya.